All right, let's talk about a core principle of professional test automation, building tests that are truly independent and isolated. Now, this isn't just some nice-to-have best practice. This is the absolute foundation for building a reliable and scalable test suite that you can actually trust.
So let me ask you this, and be honest. Have you ever kicked off a test run, seen one tiny test fail, and then just watched in horror as it starts a domino effect? Suddenly, you have a sea of red, 20 other tests have failed. You spend the next few hours digging through logs, only to find out the real problem was in that first test and had nothing to do with the others. So frustrating, right?
Well, if that sounds a little too familiar, I've got some really good news for you. The problem probably isn't your test logic. It's the architecture underneath it all. It's a flaw in your test design. And that is exactly what we're going to fix right here.
To really wrap our heads around this, let's start with a super simple analogy. Imagine you're a teacher trying to run a final exam.
On the left, you've got the chaotic classroom. This is where your tests share all the same data and resources. One test makes a mess, and the next one comes along and trips over it, causing a failure. It's total chaos. But on the right, that's our goal, the isolated exam booth. Here, every single test gets its own pristine private environment. It has its own dedicated data. So now if a test fails, you know for a fact it's a real bug, not just some side effect. Debugging becomes a million times easier.
And that, right there, brings us to the formal definition of test isolation. It's just the practice of making sure every test is its own independent little unit. It doesn't know, and it definitely doesn't care about any data or state left behind by any other test. This is the whole game.
Okay, the theory makes sense, but how do we actually build these little exam booths for our tests? Let's get practical. The entire mechanism, the whole secret, hinges on one powerful idea. You have to explicitly control the test environment. And we do that using special routines that run before a test starts, that's the setup, and after it's finished, that's the teardown.
So here's the life cycle for every single test. Step 1 is setup. Before anything else, your code makes a post request to create a brand new, unique resource just for this one test. Step 2 is execute. This is your actual test logic, validating that specific resource. And step 3, the one everyone forgets, is teardown. And this is critical. Whether the test passes or fails, you make a delete request to clean up that exact resource, leaving the environment spotless. Clean in, clean out.
Now, the best part is you don't have to manage this all manually. Modern testing frameworks have got your back with powerful tools called hooks. If you're in the Java world, you've got annotations like @BeforeEach for your setup logic and @AfterEach for your cleanup. The framework guarantees that these will run before and after every single test method, automating your little booth building process.
Okay, that's great for the data inside our own application. But what about the stuff we don't control? What happens when your test depends on some flaky third-party API that might go down at any minute? Well, that shatters our perfect little world of isolation.
This is where the pros use a technique called service virtualization. You've probably also heard it called mocking or stubbing. The idea is simple. We create a fake, simulated version of that external API, a stand-in that we have 100% control over.
So instead of your test making a real network call to some unpredictable service out on the internet, no, it calls a local, completely stable mock that you control. You can tell it to return a success response, a specific error code, even pretend to be slow. You are in complete control, and your test is perfectly isolated once again.
So, we've done all this work. We've built our isolated booths. Why? What's the huge reward? Sure, reliability and easier debugging are awesome wins. But the ultimate prize, the real game changer, is raw, unadulterated speed.
And this quote says it all. You cannot, and I mean you absolutely cannot, reliably run your tests in parallel if they aren't independent. Test isolation is the non-negotiable golden ticket to the world of parallel execution. And the difference is just staggering. The old way, running tests one by one, a decent regression suite could easily take an hour. But with isolated tests, you can run them all at the same time, in parallel. That same 60-minute suite can be done in just 5 minutes. This completely changes the feedback loop for your entire team.
I mean, just look at the chart. It drives the point home. We're not talking about a tiny optimization. This is a massive, order of magnitude improvement. This is the difference between going to get coffee while your tests run versus going to lunch and hoping they're done when you get back. Your future self and your project manager will thank you.
Now, to really master this, it helps to know what not to do. So let's cover some of the common rookie mistakes, and then we'll finish up with the key takeaways, the pro moves from the top 1% of QA engineers.
Okay, these are the classic traps. First, relying on a shared test database, or a single test_user account. That's just asking for conflicts. Second, designing tests that have to run in a specific order. That makes your suite incredibly brittle. But the biggest mistake is ignoring cleanup. Leaving test data behind is like creating a minefield for future test runs. And finally, hard coding values instead of creating them dynamically. The moment that data changes, your test breaks.
So, let's wrap with the pro moves. First, always remember, isolation is speed. That's your #1 motivation for doing all this. Second, be obsessive about controlling the environment. Every test is responsible for its own setup and its own teardown, no exceptions. And finally, decouple your dependencies. Mocks are your best friend for creating a stable, reliable test environment.
And really, that's it. I know it sounds like a lot of discipline up front, but I guarantee you, if you master these principles of test isolation, you're not just writing better tests. You are operating at a level that puts you way ahead of the vast majority of engineers in the field. You've got this.